All right, it's Mr. Smith. I'm back and better than ever. Video number 2. So first we talked about amplitude, and that determined the vertical stretch. Now we're talking about the period of the graph, and this is the hardest one to understand. So if you need to pause, please watch this video twice. I'm going to keep it short. In standard form, what is standard form again? I hope you can say it by now. A sine B. Then the x goes inside with a plus or minus c and a plus or minus d at the end. We've talked about amplitude. Now we're talking about the period of the graph. And the b helps determine the period. It doesn't just show us the period, it helps us. Here's the formula that you need to memorize. The period of the function can be determined by 2 pi divided by b. Now here's why. We learned on Tuesday that graphs, and think about the unit circle. We go from 0 to 2 pi on the unit circle. If this is 0 on the x-axis, and then this line right here, so if this first line is 0 and the second line is 2 pi, the middle line is pi, the middle between that is pi over 2, and then the middle between that is 3 pi over 2. Basically, we're just plotting our coordinates is what we're doing. It takes 2 pi radians for one complete rotation of the sine graph. It takes 2 pi radians for one complete rotation of the cosine graph. But that graph can be shrunk. Not only could a sine graph look like this, like we've seen it, but what if I shrunk it down and did it in half the time? That would be a period of pi. So the definition of period is how long it takes the graph to complete one cycle. Okay? If it takes it 2 pi to do one complete cycle, then the period is 2 pi. If it just does this, 1 pi, then the period is 1 pi. We could do the whole graph in this little space and just go like this. Okay? So the graph can be stretched horizontally. A period is a horizontal stretch. We'll take the normal graph and either stretch it and pull it much longer, or we'll bunch it up and let it complete its cycle in just a little bit. Here's what I mean. The period of this first example, notice there's a 2 here. So we're going to say 2 pi divided by b, which is a 2. The 2's cancel, and our period for this graph is pi. So here's how I've taught students to do it for years now. I think it's wise to put a little dashed line when you're first learning to know that that's kind of where your graph is going to end. Because when you see that visually, we've graphed the sine graph a lot, and we know that the sine graph starts at 0, ends at 0, and then you can just look for your middle point. Yes, it's a little different. This is pi over 2, and this is pi now. It's not stretched all the way out, but we still know sine's going to have 3 points on the x-axis. So there's the 3. We learned last video about amplitude. There's not a number there, so we know it's going to go up to 1 and down to -1 like a traditional sine graph. And then we can just connect our dots. So notice, the period this time was only pi. So we did the complete cycle with just going the first 2 tick marks. Okay, this is pi over 2, and then we finished at pi. Let's look at another one. Look at this number, cosine of 4x. So to find the period, which is how far this graph is going to be stretched, then we got to go 2 pi divided by that number. And you can see 2/4 is going to reduce to be pi over 2. So the period is pi over 2. So I'm going to put a dotted line right here at pi over 2. Excuse me. I'm going to have to fit the entire graph in that little section. So we know that cosine usually starts at 1, it ends at 1, it drops to -1, and then it has the 2 other points on the x-axis. Look, there's our v. It's really small because we bunched the graph up. The period is much shorter. And now we just connect our lines. Alright? So in summary, before we do 2 examples and this video is over, the letter b in your equation, whatever number is there, that determines your period, which shows how far the graph is stretched horizontally. How long does it take to complete one cycle? Okay, and remember, we talked about this on Tuesday, but one cycle of the graph includes our 5 key points. For the sine wave, let me one more time just number them here. Here's point 1, 2, 3, 4, 5. There's our 5 key points. And for cosine, we've got 1, 2, 3, 4, 5. Okay, we're always made out of 5 key points. So let's try 2 examples where, not only do we have an amplitude, but we also have a period change, so A and B. So here's how I would do this example. I see that it's a sine graph. That's the first thing. I see that it's an amplitude of 3, and it's positive, so that means it's going to go up to positive 3 and down to negative 3. But then I need to find my period. There's a 1/2 here. So I'm going to, over here underneath it, I'm going to say 2 pi divided by b, which is 1/2. And remember, whenever you divide something by a fraction, that's the same thing as if you were multiplying by the reciprocal. So instead of dividing by 1/2, I'm going to actually multiply by 2, which gives me 4 pi. So this is the first one we've had that's actually going to be stretched longer. Okay, so take a look. That's why I gave you extra room. We can say here's pi, because every tick mark is pi over 2. So there's 1, 2, there's pi, there's 2 pi, then 2 more makes 3 pi, and then 2 more makes 4 pi. Okay, so that is where I'm going to draw my dotted line, just to give myself a visual of how far I need to go. Now watch how simple this is. Instead of me trying to get every single point exactly right off the start, we know where the sine graph always starts. It starts at 0, 0. Okay? We haven't shifted any yet. That's the next video. So when you see a sine graph that doesn't have a vertical shift, it starts at 0, it ends at 0, and then the middle point is at 0. So what is right between 0 and 4 pi? Well, that will be 2 pi. So now I have 3 of my 5 points. The other 2 are going to be affected by this A value, the amplitude. It's a positive 3 there. So my hump on the sine graph is going to go up to 3, and then the other one's going to go down to negative 3. And notice, this is my regular sine curve. It's shifted, not shifted, but stretched vertically and horizontally. It took 4 pi for it to complete the 5-point cycle. All right, let me do one more. We're going to omit these for now because they have vertical shifts. We're doing that on the next video. So we'll do this one. Okay, I challenge you to pause the video and try to do it by yourself and then check with me. So pause now, try it yourself, and then check. So here we go. We know our A is 2. That's our amplitude. We know our B is 3. So I'm going to do 2 pi divided by B. And 2/3, that just can stay. They can't really reduce. So my period is 2 pi over 3. Now I know that's kind of weird, but take a look. We know that every tick mark is pi over 2. So this is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. Where do you think 2/3 would fit on our line? 2/3 is a little more than 1/2, but it's less than 1. So I'm just going to estimate that this is my 2/3 line, and that's the period. And you might be thinking, but wait, now it's off. It's not going to land perfectly on the marks. You're correct, but watch, I'll switch to blue. What do we know about the cosine graph? We know that normally it starts at 1, but look at my amplitude. There's a 2 there. So cosine starts at 2. It's going to end at 2. It's going to drop to negative 2 in the middle, and let's just guess where the middle is. That's about right in between our 2. I'll draw a second red line. That's about right in between those 2 lines. So it starts at 1, ends at 1 or 2, drops to negative 2, and then remember the cosine makes the V, so we'll put our 2 in the middle, and then there is our graph. So that one was a hard one for you to try on your own, but rewatch that little portion of the video and watch me create that graph. So, in summary, and then I'll wrap video number 2 up. We learned about amplitude in video number 1, and we just learned about period. That's the definition of the period of a function is how long it takes for it to complete one cycle. And remember, we learned that our cycles are the 5 points. Okay, so for sine, one cycle is just the one hump up and one hump down. For cosine, it's where it starts up high and then it drops and comes back. That's one cycle. Okay, so you are ready now to be able to graph things that have both an A and a B. The next video will cover C and D. Thank you.